All right, we're going to finish up chapter 2 with 2.7. It's the names of compounds. So we're going to be naming different compounds. First step here is monatomic cations. Remember, cations are the positives, so it's the monatomic, meaning one atom, in the positives, and you're going to take the name of the metal from which they are derived. So Na+, so if it starts with Na, the first word is going to be sodium. If it starts with K, the first word is going to be potassium. The only exception is that many transition metals can form more than one type of cation. So we use a Roman numeral to tell the difference. So like Fe+2 is actually iron, Roman numeral 2. Fe+3 is iron, Roman numeral 3. I'll write over here too because my line got moved. So it still starts with that word iron. It just gets a different Roman numeral. We're on the last page here. Mine didn't flip over because I have a different printout on the screen. But you want to turn over to the last page. Monatomic anions, so negative charged ones that are one atom. The difference is you're not just going to say the word. You're going to add the suffix I, D, E to the end of the word. So here we have nitrogen. So we're going to take the stem, nitra, at IDE, so it's nitride. Oxygen is going to be oxide. And sulfur is going to be sulfide. You can see this on page 43 if you need more information on it. That's why when we have sodium and chlorine together, we get sodium chloride, right? Ionic compounds. Now, an ionic compound, ions are made of a metal and a non-metal. Okay, so first you're going to name the metal, or the cation. And then you're going to name the non-metal, or the anion. Okay. Now, binary molecular compounds, a molecule is made up of a non-metal and a non-metal. We're not going to look at two metals together. They're metallic bonds, and they don't usually have names that follow a pattern. Like brass is steel. Those are metallic bonds, but they don't follow a pattern for naming, so we're not going to look at those. But you do want to look at these right here. These are diatomic molecules. Anytime these elements show up alone in an equation, they're always going to have this little number 2. Because they're so reactive, if there's nothing else to bond with, they'll bond with each other. And a way to remember it is an acronym. HOF, hydrogen, oxygen, fluorine. Bromine, iodine, nitrogen, chlorine. And if you say this word, it's Hofbrinkel. So I may say, oh, that's a Hofbrinkel. And that means if it's sitting by itself, like H2 plus O2 yields H2O. So we want to make sure, let me just balance it. We want to make sure that if you have hydrogen sitting by itself, it's got a little 2 next to it. If you have oxygen sitting by itself, it has a little 2 next to it. Now you notice in a compound it doesn't matter. But when they're sitting by themselves, they can't just be H plus O yields H2O. You have to have H2 plus O2 yields H2O. There are diatomic molecules. All right, so rules for naming molecules. Remember, molecules are 2 non-metals together, which means they're both on the right side of the periodic table. But they're very similar to ionic compounds. However, now you got to put a prefix in it. So you still name the metal and then the non-metal with IDE, but you're going to have to put prefixes in it. So if, say, there's only one, you're going to use mono. But notice that's only used for the second element. None of these are going to start with mono, because then if it's alphabetized, you have lots in the M section. So we do not start with mono. But if you have one of the second thing, one anion, you are going to put mono in. Di for 2, tri for 3, 4 is tetra. You may have heard that game Tetris, where all the shapes have 4 parts. Okay, every single one is 4 parts. That's how I remember tetra for 4. 5 is penta. 6 is hex, or hexa. Hepta for 7, pta. Octa is 8, nona is 9, and deca is 10. Okay, so those are our prefixes, and yeah, you got to memorize those. So let's say we have N2O3. I have two nitrogens, so dinitrogen. I have three oxygens, trioxide. So I still take the first word, I still add IDE to the end of the second word. NF3, nitrogen. Remember, we don't start with mono. Trifluoride. I have PCl5. I have a phosphorus. Watch your spelling. Pentafluoride. You may see that as pentachloride also. Both are fine. If you drop that A, it's not a big deal. For this next one, we have 2 phosphorus, 5 oxygen. Diphosphorus, pentoxide. They do usually drop it with oxygen, I guess just so you don't have 2 vowels in the same spot. Now be careful. O2 right here. Do not say dioxide. We just said what the diatomic molecules are. This is just plain old oxygen. That is a way that I trick people on tests and quizzes, so be careful. This last one over here, CO2, we have 1 carbon. Remember, we don't use mono, so carbon, 2 oxygens, dioxide. You've probably heard of carbon dioxide before. Now here's some common names of molecules. You don't have to memorize them all, because you don't use them all that much. But I do want you to know water is H2O, hydrogen peroxide is H2O2, ammonia is NH3. Those 3, and the 3 at the end. Nitric oxide, nitrous oxide, and methane. Those are the ones we're actually going to use later on. So those 6 you do have to commit to memory. Very last thing we're going to do in this whole chapter is naming an acid. Okay, certain binary molecular compounds that start with hydrogen form acids when they're combined with water, such as this one, HCl. We've used that a lot. We have hydrogen chloride, if you just name it. But if I put that into water, I have hydrochloric acid. Okay. HBr, I added to water, I have hydrobromic acid. You'll notice this little AQ here. That means it's added in water. See the AQ, you know it's going to be an acid. It's going to be named this way. HI is hydro or hydriodic acid. That's it. The other ones, like if we have H2SO4, if you have an oxygen in there, you drop the hydro. Okay, the oxygen kind of takes over. So this is sulfuric acid. Okay, so H2CO3 we know is carbonate. That's carbonic. Okay. So if it ends in ate, then the acid's going to end in ick. If you ate something, you didn't like it, it's ick. Now the problem is if we have nitrous, if we have nitrite, I don't think it's one that, or hypochlorite, that's one that you memorize. It's HOCl, right? Hypochlorite. We have an oxygen, so we don't use hydro, but it ends in ITE. It ends in ITE, the acid is going to end in OUS. So it's hypochlorous. Oops. CHLOROUS. Acid. Okay, so ike goes to us, ate goes to it. You really don't have to worry about that when you have an oxygen involved. Okay, so these have oxygens. There's no oxygen involved. It's nice and straightforward. Hydro, add ick to the end, and acid. And that is it for chapter 2.